Welcome back, class, for another exciting science adventure with Sian and Tennille. Today in our interactive lesson we are going to learn about air pressure. Have a quick look at this clip. Close your eyes and listen. You're right, it's the wind. Has anybody ever wondered what makes the wind? We feel the wind every day and yet we can't see it. We can see how the wind affects the things around us, yet we have never actually seen the wind. Fascinating. Well, it has a lot to do with air pressure. And today we are going to investigate air pressure and perhaps find out what air pressure has to do with creating wind. Are you ready to put your thinking hats on? Because we're about to start our class adventure to find out. The first thing you need to know is that air takes up space. That's right, you heard me. Air takes up space. You didn't think that just because we couldn't see it means that it's not matter and doesn't take up space, did you? Make sure in front of you you have the equipment for experiment 1. Here is the equipment list. Now that you're ready, let's try this experiment.
Alright, here's an incredibly easy experiment that you guys can do at home and really good in your classroom. Too easy. Okay, so what we've got here, jug of water, tissues, clean, clear jars, and ping pong ball.
Make sure you have all your equipment ready for experiment 1.
Alright, so straightforward. What you do is you throw your students, you put your ping pong ball in and ask, if I put the cup over the top, push down, will the ball stay at the top of the water, go to the middle of the water, go to the bottom of the water?
What do you think will happen?
Okay, so you get your glass, turn it over, push down. Alright, goes right down to the bottom.
Now you try. Why do you think it does this? Why do you think the ball stayed at the bottom of the glass? Let's see if you're on the right track.
It must be full of air, so the easiest way to show that it must be air inside there, not water, is to get some dry tissues. So you get your student, check that it's dry, and put it inside. Get it all in there, so you know it's dry in there. Put it upside down, straight back over your ping pong ball. Push down. Ball goes to the bottom, so there must be air inside the glass taking up that space. Take this out, and carefully, without letting the drips go on the tissue, out we go. She's dry.
Now it's your turn. This experiment shows us that even though we cannot see them, we are surrounded by air molecules. And these air molecules take up space in our environment. Now let's investigate air pressure.
Air pressure is the measure of the force of the air pressing down on the Earth's surface. Air pressure depends on the density of the air. Denser air exerts more pressure than less dense air. Air pressure on the Earth can vary considerably from location to location due to unequal heating of the atmosphere.
That's why it's so cold and hard to breathe up here. I'm out of here. Let's experiment with air pressure with Joel and Howie. Before we get started, you will need to have the listed equipment. Alright guys, I think we're ready.
Got our safety goggles on. We're ready
I'm
to
Joel.
go.
This is Howie.
All right. What are we doing today?
We're talking about air pressure.
Air pressure, okay. Perfectly empty balloons, right?
Right.
Empty. No.
Nothing in it. Nothing
Wrong.
in it.
There's a little bit of air in there.
There's
Now,
a little
air,
bit in there. Oh, you're right.
there's a little bit of air. Air takes up space.
Okay.
Just
Okay.
air takes up space.
right.
Let's see. Just give a little balloon. Show you they're real balloons. Now, whoa, there it goes. Air takes up space.
We already know that air takes up space.
You can do with anything. Let's have a little race.
Little race. I've got a balloon.
Ordinary balloons in an old water bottle,
Old water bottle.
And stretched around the top.
In pairs, put your balloon inside your water bottle and stretch the end that you blow into around the top so that you are able to blow into your balloon.
We're going to race.
We're going to race. Race to what?
See who can blow up their balloon in the bottle fastest.
Now, I'm a little worried about this. Mine has my name on it, and I didn't do that. So I think Howie set this up ahead of time. Hold on. Okay, ready? Safety goggles on.
Safety goggles on. Here we go.
Ready?
Ready? Set. Come on, dude. You're turning purple. You let the old guy beat you.
Some veins popping out of my forehead there.
Hey, come on. Try it again. Try to give it another try.
All right. Hold on. You ready?
Well, let's see what you think.
Okay. 1,
Ready?
2, 3.
Come on, dude.
Oh, why won't mine blow up?
Why do you think that Howie's balloon blows up, but yours and Joel's won't?
Oh, I'm a little dizzy.
You can't blow it up because you're not strong enough.
I think that you're all strong enough to blow up the balloon, so why do you think you can't? What could you change about your bottle that will allow you to blow air into your balloon?
What? Yeah, you just got to have big lungs, big guns, everything, all that good stuff. All right. Now,
Okay, so what's
well,
I think there's something to do with the fact that my bottle is titled and his bottle is his name, and there's a hole
Right.
in Howie's bottle.
right there, pretty hard to see.
That makes sense because the air inside the bottle in
right.
mine doesn't have anywhere to go.
No.
So when I try to add more pressure inside of here, the air's not letting it happen.
There's-
But in yours, when you add more volume, more pressure in there, the air escapes through that hole. So if you punch a little bit of holes in here, the air will escape. You can blow up the balloon. Otherwise, you have the air pressure trapped inside of here. You can't add anything else. This bottle is definitely not empty.
Okay, watch. I'll prove it to you. I'll cover the little hole with my finger. Bingo. Air
Science.
takes up space.
Yep, that's science.
But, okay, folks. That's your little lesson for today. Air pressure, air takes up space.
Follow your teacher's safety instructions to poke a hole in your water bottle and try your experiment again. So what did we learn about this experiment? When the balloon is being inflated, a lot of the air is being forced inside it. This is air being compressed as it is squashed together, and so it is at a high pressure. If you let go of the end of the balloon, the air inside will rush out to where the pressure is lower.
Cold air is heavy and the air molecules need less room to move, so you can fit more of them into one area. Warm air is lighter and holds fewer molecules because they need a lot more room to move. So, cold air is high pressure because there are more molecules pushing on the Earth's surface. And on the other hand, warm air is lower pressure because you have fewer molecules in the area pushing on the Earth.
These air pressure differences cause the movement of air, which we call wind.
Push down. Alright, goes right down to the bottom.
Air pressure is the measure of the force of the air pressing down on the Earth's surface. Air pressure depends on the density of the air. Denser air exerts more pressure than less dense air. Air pressure on the Earth can vary considerably from location to location due to unequal heating of the atmosphere. These air pressure differences cause the movement of air, which we call wind.